Hello friends, in this lecture I will talk about the most basic concept of chemistry, that is the mole concept, and probably it is one of the confusing topic for a student who has just started his preparation for IIT. But let me assure you that it is also one of the easiest topic that you will ever be studying in chemistry. So first of all, we will understand the meaning of a mole. What is a mole? Then we will talk about the Avogadro number. Then we will derive the formula and we will solve some examples based on the formula. Okay. So in chemistry, one mole, one mole is a SI unit for measurement of amount of a chemical substance. So what are the common units that we use to measure the amount of substance? The common units are mass and volume. So basically in this chapter we will relate mass and volume with number of moles. So in chemistry, most of the time we will use mole as a unit for amount of substance and not mass and volume. So in chemistry, this 1 mole is just a number, and this number is 6.022 into 10 to the power 23, and we call this number as Avogadro's number, and we represent it by a capital N with a subscript A. So I can write that 1 mole of any substance will contain this Na number of elementary entities, and these elementary entities can be anything. It can be atoms or molecules or ions, electron, etc. Okay, so if I write 1 mole of atoms, so this means 6.022 into 10 to the power 23 atoms. So from this I can say that 1 mole of atoms will be collection of 6.022 into 10 to the power 3 atoms. Similarly, if I write 1 mole of electrons, so this is also means that's 6.022 into 10 to the power 23 electrons. Collection of this much of electrons will be equals to 1 mole. Okay. Now let me give you an idea about how big this Avogadro's number is. So if a person is counting one coin per second, then we need to estimate the time that will be requiring to count 1 mole of the coin. Basically we need to find out how much time will be requiring to count 6.022 into 10 to the power 23 coins. So it's given that a person is counting one coin per second. Okay, so the time will be equals to 6.022 into 10 to the power 23 seconds, and if I divide this time with 3600, then I will get a time in hours. If I further divide by 24, then I will get a time in days, and if I further divide it by 365, then I will get a time in years, and this will come around 9.1 into 10 to the power 16 years. Okay, so this much of time will be required to count 1 mole of coins. So now you tell me that can a person count 1 mole of coin in his lifetime? No, he can't, because the average lifetime is around 100 years, and time required to count 1 mole coin is 10 to the power 16 years. So now let's find out how many lifetimes, right? So 9.1 into 10 to the power 16 divided by 100, that will give me around 10 to the power 14 lifetimes. Okay, so if I devote 10 to the power 14 lifetimes, then only I will be able to count 1 mole of coins. So now you can think of how much big this number is. Okay, now let's come to the definition that you will be studying in any book or at internet. So 1 mole is a unit of measurement used in chemistry to express amount of a chemical substance that we know already, and is defined as the amount of any substance that contain as many elementary entities as there are atoms in 12 gram of pure carbon C12, and these elementary entities can be atoms, molecules, ions, anything, right? So if I take the last line of this definition, then it's saying that 12 gram of carbon C12 is equivalent to 1 mole of atoms of carbon C12. So in 12 gram of carbon C12, I will have 1 mole of atoms. And in 1 mole, we already know that how many atoms? 6.022 into 10 to the power 23 atoms. Okay. So now you must be confusing about this 12 gram and C12. So this is just a standard used in defining mole in chemistry. So this is just a standard. So now tell me, what is the mass number of carbon? Mass number of carbon C12. So mass number of carbon C12 is 12 AMU. That's why I have written it as carbon C12 and not carbon C14. So this is also equals to mass of one atom of carbon C12. Okay. So basically mass of one atom of carbon C12 will be equals to 12 AMU. So if I have to find mass of 1 mole of atom, 1 mole of carbon C12, so this will be equals to mass of one atom, which is 12 AMU, into number of atoms in 1 mole, which is equals to 6.022 into 10 to the power 23. And if I finally convert this thing into grams, then this will give me 12 grams. Basically mass of 1 mole of carbon C12 is 12 gram, and we also call this mass as atomic mass. Basically mass of any chemical substance, mass of 1 mole of any chemical substance is called as its atomic mass. So basically 1 mole of carbon C12 will have a mass equals to its atomic mass, 12 gram. This is also its atomic mass. So if I write the same equation for aluminium, which is 27. So 1 mole of aluminium will be equals to how much grams? 27 grams, because 27 is atomic mass, or basically atomic mass of aluminium. Okay. Now, so if I have to write a formula to determine number of moles in a given collection of mass, m. So number of moles in a given mass will be equals to mass in grams divided by its atomic mass if it's a atom, or its molecular mass if it's a molecule. This is how we determine number of moles. So far we have related mass with number of moles. Now, so if the given substance is a gas, okay, so if a given substance is a gas at some pressure P and temperature T, then it's easy to measure its volume. Now why I'm saying that it's easy to measure its volume? Let's say I have a container in which I have a gas. Now I have put a movable piston which is exerting a pressure P1, and I am maintaining this container at a temperature T1. So according to P1 and T1, the gas inside will occupy a volume V1, and if I have a measuring scale here, then I can easily calculate its volume. Okay, so that's why we will define number of moles in terms of volume. So for every gas, 1 mole is defined as 22.4 liter of gas at STP condition. Now what is this STP? This STP is standard temperature and pressure condition. Standard temperature and pressure condition. So what are these temperature and pressures? Temperature is 273 Kelvin, which is also equals to 0 degree centigrade, and pressure is 1 atmospheric, which is equals to 1.013 into 10 to the power 5 Pascal. Okay, so if I have a temperature of 0 degree centigrade and pressure of 1 atm, then I can say my conditions are standard conditions. So basically for every gas, if I take a 1 mole of any gas at STP condition, then this will occupy a volume of 22.4 liters at STP. Okay, so always remember that this volume is at a specific condition and not at some random condition. Okay, so if I have to write the formula for a gas, formula for number of moles, so basically number of moles will be equals to volume of the gas in liters at STP divided by the molar volume, which is 22.4 liters. So this is the formula for a gas. Now if I have to write a single formula for the whole mole concept, so I can write a single formula for the whole mole concept as number of moles is equals to mass in grams divided by atomic mass if it's a atom, or molecular mass if it's a molecule, and this is also equals to volume in liters at STP divided by 22.4 liters, and this is also equals to number of elementary entities divided by 6.022 into 10 to the power 23. So this is the single formula that we will use to solve numericals on mole concept. Okay, now let's solve some examples. So the first question is, find number of moles and atoms in 46 grams of sodium. Okay, now the given mass is 46 grams, right? So what is the molecular mass of sodium? So the molecular mass of basically sodium is atom, so it's atomic mass. So atomic mass of sodium is 23 grams. Okay, now if I have to write number of moles, that means given mass, which is 46, divided by its atomic mass, which is 23. This will be equals to 2 moles. So in 46 grams of sodium, I will have 2 moles. Now I know that in 1 mole of sodium, I will have 6.022 into 10 to the power 23 atoms. So in 2 mole of sodium, how many atoms? 2 times of 6.022 into 10 to the power 23 atoms, and this is the answer to the problem. Now let's come to the second example. The question is, calculate the number of atoms in part A, half a mole of nitrogen, and part B is 5.6 liters of helium at STP. So now let's come to the part A. So it's saying that 0.5 moles of nitrogen. So in 0.5 moles of nitrogen, so nitrogen exists as diatomic N2, right? Most stable form of nitrogen is diatomic. So in 0.5 moles of nitrogen, I will have 0.5 into 6.022 into 10 to the power 23 molecules of nitrogen. Okay, and I know that in one molecule, how many atoms? We have 2 atoms. In this much of molecule, number of atoms will be just equals to twice the number of molecule. That means 2 times of 0.5 into 6.022 into 10 to the power 23. So this will be equal to 6.022 into 10 to the power 23 atoms, and this is the answer. Okay, now let's see the part B. So in the part B, it's saying that 5.6 liters of helium at STP. So I have to find number of moles. So formula is number of moles equals to given volume upon 22.4. So this will give me number of moles equals to 1 by 4. Now helium, so most stable form of helium is He. So it's a monatomic. Okay, so for helium I can write that 1 mole of helium is equals to 6.022 into 10 to the power 23 atoms, and in 1 by 4 mole of helium I will have 1 by 4 into 6.022 into 10 to the power 23 atoms, and this is the answer. Okay, now let's come to the final problem. So question is, how many moles of electron weigh 1 kg? So basically I have to find in 1 kg of electron how many moles of electron will be there. Okay, now let's assume that there are n electrons, n number of electrons in 1 kg. So what is the mass of one electron? Me, that is the mass of one electron, is equals to 9.1 into 10 to the power minus 31 kg. So this will give me that n into Me will be equals to 1 kg. From this equation I can write n is equals to 1 by 9.1 into 10 to the power minus 31. Okay, so this n is the number of electrons, and I have to find how many number of moles. So number of moles will simply be equal to this n divided by Na. So this will be equals to 1 by 9.1 into 10 to the power 23, and also divided by 6.022 into 10 to the power 23. Oh, this is minus 31. So basically 1 divided by mass of 1 electron divided by Na. So this is the number of moles of electron in 1 kg. Okay, so that's it. Thank you.